So here's there's this fake feature on this pool set called com.example unsupported. And it's set to say that this is, let me actually make a distinction real quick that's important. So so actually what it allows you to do is you'll be able to open the pool read-only still. So, yeah, so I'll show an example. So here's there's this fake feature on this pool set called com.example unsupported. And it's set to say that this is, let me actually make a distinction real quick that's important. So we're calling these features for read and features for write, and it's a little confusing nomenclature. Features for write means you need to support this feature in order to write to the pool. So these are the ones that you can still open in read-only mode. Features for read, you need to read from the pool, and there's no way to write only to a pool, so these are basically features you need anytime for anything. So that's just, so here we've set a feature for read on the pool called com.example unsupported. So there's no way to import this pool without supporting this feature, which we don't. So it prints, when you try to import it, it prints a message that this pool uses the following features not supported on the system. All features can have a little descriptive string that's actually persisted to disk. So if you can't kind of express what your feature is in the short string, in 1 or 2 words here, you can actually put a little descriptive string there to kind of indicate to people what it is that's going on here.
I imagine that you could also use this to say, like, you need to upgrade to Delphix version 3.2 in order to access this pool or something like that.
Let's see. Right, so and then this one, there's a feature for write. So if you try to import it, just like I tried to import this one, it actually says that you can't, I don't know. I thought there was code that said that I ran this and actually copied and pasted, so it must not be there, but there should be, it should actually give you instructions on you can import this read-only, and that's trivial to add in there, so that'll be there.
I think if you do zpool import without the pool name, it will give you that information. So like if you wanted to see what pools could you actually import, it would say, oh, example can actually be imported read-only.
All right. And then here, there's just an example of importing the pool read-only, and I get the empty prompt because it worked. Question?
So what if you have a pool property that only really matters when you use it? Not that I can think of any off the top of off the top of my head, where if you don't have crypto, if you've built crypto, but you're not using it on any of the data sets in the pool, where does that fall into your read-only whatever
Chris
taxonomy?
is a perfect example to address that because async destroys stuff. So if you still have that question in a couple of slides, then ask it again.
Maybe I'm not understanding. That's the enabled.
That's enabled versus
Exactly.
active.
We're going to see an example of
Okay,
that.
beautiful. Great.
All right. So kind of as, there's a couple slides here on like kind of guidelines for how this should work, because this is a pointy sword you can stab yourself with. So we always want to aim to, like, the job of the average system administrator shouldn't have changed from before. He gets the new software, he upgrades all pools to get to the newest on disk format, everything's enabled, everything's good. There's the added bonus here now of, like we were saying, everything's enabled but not necessarily not necessarily active. So if you don't like create the new RAID Z or whatever VDEVs, then you're fine. Then you'll be fine, and you can still downgrade the software again. So the common case we want to keep always is this. We don't want people to be in the business of like, handling weird dependencies, and the average person should never have to see this list of features or care what they are, unless they can't import them because whatever software they're on doesn't work.
But zpool upgrade is a much safer operation.
Yeah.
Because if you don't use any of the new features, you're not going to go to active.
Yeah.
So.
Let's see. There's another thing which is kind of like, and this I'm not sure that this is necessarily like an individual working on their, on some big system. This is more like if we at Delphix want to evaluate whether this new feature we pulled from illumos is going to affect the way our, something that happens in our appliance, we might want to evaluate these and enable them individually over time, which is something that this gives us, rather than like if you want to get whatever's in 33, you must have 31 and 32. Yeah, and this is, I mentioned this earlier, but it leaves open the possibility for features to move themselves from active to back to enabled, in which case, they're only stopping you from downgrading while they're still in use. So let's say you remove whatever RAID Z devices, if you can manage to do that from your pool, and go
So
back.
like with your example, maybe you can use this example.
Yeah, this actually, yeah, that's right, perfect. This fits much more. If you have like some feature that you enable on specific data sets, like I guess maybe dedupe.
Oh, crypto.
Crypto.
So you would enable encryption on the entire pool to say that now you can use encryption on this pool.
Yeah.
But then you would create certain data sets that have the encrypted property set. So then we can say that when you delete all data sets that have encryption on them, then the feature could go back from being active to just being enabled. And then you could export the pool and import it onto a system that doesn't know anything about encryption.
That would be up to the implementation of the feature to make
Yes.
sure the right thing happens.
Yeah.
Yeah,
So
and
this
I
is
get
like best
to that in a
practices
little bit, I think,
would be
too.
to have the feature know about that and do all this stuff, and that would be part of, we would enforce that through code review,
Okay,
basically.
no, that's cool.
Yeah, so we added one feature, async destroy. This is right now. So I just did. Yeah.
By like 10 orders of magnitude.
So there's in the old world, if you run ZFS destroy some file system, that just kind of waits around until all of the blocks from that file system have been freed. So it's a couple gigabytes, that can be seconds or going to minutes. Or hours, I guess.
Terabytes forever.
And then I've been told, I never bothered to test this myself, but I've been told that if your system crashes during that, it just hangs during the boot until it finishes.
This kid hasn't suffered enough.
So in the new world, basically the destroy operation is a single atomic metadata operation that kind of unlinks it from all the directory structure stuff, grabs the root block pointer of everything, slides it over to a free list, and the whole thing gets freed in the background by kind of spare cycles. Basically any transaction group that goes out that's not full just frees a couple of the blocks off.
I don't want to give a dental exam to this gift stallion, so thank you so much for this. But what is the observability into? So I mean, obviously on a transaction group, you're continuing to do deletions. How do we know when a deletion is done? How do we know that we're seeing I/O performance, I/O latency, because we're still got this latent destroy going on? Is there any observability into it? I mean, it can be as simple as SDT probes. I don't think we need.
There is actually.
Or K-stats.
We left in the possibility of still having a wait for this to finish kind of thing, but there's no.
So I think that the way that we envisioned exposing this, which is not the case today, is with zpool status.
Yeah.
So the other example of something like this is zpool scrub.
Yeah.
Where you kick it off,
Yeah.
it runs for a long time in the background, and at some point it completes. There, obviously, you need to know about what's going on because you want to know whether it succeeded or not. So we envision exposing this with zpool status, where we would say, deletions in progress, X gigabytes remaining to be recovered.
Perfect. Awesome. Yeah, that is great.
And does this actually prevent you, if you're doing a range of snapshot destruction, does this in any way enable you to start doing other operations immediately, even though this is running in the background, you want to go create new ones?
Yeah, absolutely it does. So
Because
this is
the atomicity might be different. One might be saying, I need to delete these 3 to make this one new snapshot because my size
This is
bigger.
Snapshots already did this actually.
Okay.
This has always existed. This is for file systems, but there's nothing that's.
Yeah, not always.
As in the world that I cared about.
Always been the last 4 months.
But I think the question is still valid, and that's actually kind of one of the reasons that we implemented this is that in the appliance stack, we need to delete snapshots, delete file systems, etc., and then create new ones or whatever, manipulate things. So with the old model, you would have to delete it, wait for that to complete, and before you could go and create another one with the same name, for example. So to work around that, we did things like
No, please. Don't say what we had to do.
We also did something. even
We also
more
did
horrible.
something
Did the Schrock, was it more horrible? Only Schrock can be the judge of whether it was more horrible or not. The horribleness is
So
awful.
basically,
It's unspeakable.
what happens is when you do the destroy, it's completely erased from like its relationship to everything else in the system. So you do the destroy, and the snapshot or now file system is totally gone from the point of view of creating something with the same name, destroying its clone origin. If you're say you destroy a clone, the origin of it can be immediately destroyed as well, while the file system is still being the clone is still being destroyed in the background.
Because if you talk about this and even think about libZFS2 potentials, my main concern as sort of a user of these things is there's certain actions that you can do that you're going off to the Neverland, right? You're saying, because you don't know it's going to return back. You're starting an operation receiving the sequel status and saying, hey, what file's really missing? That you don't get a response back over a period of time. And I would love to find a way, maybe removing the caching in libZFS2, but to find a way to really have a quicker turnaround so you can get status. Say, I don't really know the answer for all of us yet, but let me get back to you with the rest of the answer for next time we call equal status. You'll get an answer, a fuller answer then. But I can, I'm worried about making sure we reduce all these points that say, hey, I don't know the answer, and you're going to wait for a long time until I give it to you. Any of these operations. That's the sort of like the weakness I always perceived. And this seems to be addressing the most major one everybody knows about.
So this, I think, it addresses that from the point of view of, as soon as it returns, it's giving you the answer of like, it is either destroyed or it's not destroyed, right? It failed or succeeded. And then in the background, we're going and recovering the space.
What happens if the issue is async destroyed while one is in progress?
You shouldn't be able to get the name, right? The name's
What happens
gone.
if you see
Of a different
do
data
another
set?
destroy?
Yeah.
It's
Yeah,
just like, then you work on.
Would that just get appended to the current list?
Yeah, exactly.
Yeah.
So that would just.
From the only perspective I can see from which this matters is like weird I/O usage and like your disk space. Like from every other perspective, the destroy
immediately
is
gone.
done.
Yeah.
Yeah, I think just having the status return a percentage, or not even percentage, just like I'm still doing it. My percentage would be great, obviously.
I think probably what we do is like X gigabytes remaining to be
Oh, God.
created.
The accounting's
because
all
the
there.
percentage is a little bit nebulous because it's like,
Yeah.
I did one destroy and then I did another destroy, so they're both going on at the same time. Is the percentage of both of them, and then when the first one is done, is the percentage now just of the second one, or was it of the two still? Like that's a little bit
More
confusing.
like, if you wait until the end of time, I will definitely get rid of this amount of
Yeah.
time.
Yeah.
And yeah, so going back to the active versus enabled, basically the background destroy feature is active while it's background destroying things, and while it's all gone, it's like undoes all of its on-disk format changes and it goes back to being enabled.
And what's the status of this work? I mean, is this a dream I'm having? Is this actually happening?
This is done.
Did I get in a car accident on the way down here?
Everything I've spoken about so far is done, right? Yeah.
So,
First prize.
so first prize. Can't stop.
To the men who do not talk about things that are not done. No
Or
paperwork.
things that existed more than 4 months
So
ago.
this
No
will be,
paperwork.
is this going to be pushed up at, I mean, is this like pushed up in the next 6 months or whatever? I mean, is it-
Definitely within the next 6 months.
That's awesome. That is so awesome. Sprinkle the implementation over as many files as possible, please.
We are legally 6 months seems a little.
Does that mean skirted? No. Just sprinkle the implementation over as many files as possible. I want to see copyright Delphix as far as the fucking eye can see.
That will not be a problem.
Between Chris and I think that we've touched probably almost every file in ZFS.
Well, once you finish, libZFS2 and yeah. All right, so
Another quick observability question for you about the active to enabled transition.
yeah.
Is there a way to observe why is something active? I guess that it would depend on each feature, right?
Yeah, it's tricky because it depends on each feature.
Yeah, that count is feature dependent. So the feature is allowed to use that however they want. So in the case of this,
I don't think we've gotten to the count yet.
Oh, you're talking about that. Go ahead.
Okay.
But
Yeah.
one could imagine
But-
in the zpool man page, as features get pushed up, they have a description of what they are, when they become
Right.
active. when
I was
they
actually
become
thinking we have like a
inactive.
ZFS-features man page, just separated out, have a big list, says like this depends on such and such and whatever. It's kind of it's tricky. There's no good view for like the user and what dependencies are right now. You just kind of enable something and all the dependencies are suddenly enabled.